So we are back with the battery build, and as you can see last night I put these on again, so I put them pretty tight, and that's actually going to cause a problem here. And so we have two battery packs actually right now. We have one down here and one down here. You can see that the main positive will be down here and the main negative will be here. So to make this one pack, we need to connect this negative to this positive. And for that, I have really thick cable. So one thing I wanted to show you is I bought another two things for today to be able to continue. One is, let's see if this one. So to be able to push this one, I needed this. So you basically just put it in there, and then you hammer it to place like that. You put that one in there and you hammer. Difficult to do with one hand right now. But I wanted to show you something else. If you're ever doing anything like this that might be in a humid environment, like the ocean or a lake, you should have tinned copper cable. I can't speak anymore. So I have put one on already, and I have this one, which I'm gonna add. And I got something else I couldn't find locally, which is so weird. This shrink wrap thingy, shrink tube. I don't know what it's called in English, whatever. But yeah, so we're gonna add that on these, and hopefully we can protect as much as possible, because I want to protect as much as possible from having an opportunity to get a short. So we're gonna connect here, and then we're gonna connect the other one there, and I think I'm going to put it like that so it kind of pushes in the cables. They can run freely, but I'm probably going to tape them with a Kapton tape just so they don't run around freely like right now. And yeah, so that's the project for today. Connecting the positives and negatives, and then let's see what fun we can do to next step. Maybe continue with a battery box build. That would be fun. So voila, they are now on. I used this one, a little burner. You could use a cigarette lighter. But yeah, I prefer that one. It goes a little bit faster. And this is pretty tight. And it creates a barrier for humidity to start getting in there, which is really nice. So next thing is to start screwing it on. That's what I'm gonna do next, so that we actually connect these two. So yeah, let's do that. Okay, so I have now put these on. And I don't have any good way to kind of hide this. I definitely don't want these to be exposed like this. So for now I'm gonna take some electrical tape, but I need a long-term solution. I couldn't really use these over. They just wouldn't get over. So I'll have to find something else. I just don't know what yet. So we'll put electrical tape on these. But I also want to show you something. When I turn this on, because they hadn't been connected, and I clicked this, which is kind of a Bluetooth unit for the active balancer. So you can see the active balancer up here, you can see it blinking. It immediately started looking at the different cells, and it figured out that cell number 11, which is down here, was higher voltage than cell number 10. And how do I know which one is what? Well, we know that the negative is starting here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how I know that it's cell number 11. And the difference after these 2 days was 0.06 volts. So it hadn't dropped too much, just a little bit. So there is some voltage difference. And I kind of expect that with used batteries. But I have also taken steps to ensure, like my original plan was like here with batteries, maybe here somewhere, 11 batteries in parallels. But now I have 21 in parallel. So it went from a pretty small battery to a massive battery. And yeah. So the next step is gonna be the battery box, I think. And now we have 67 volts measuring from here to the negative pole here. my multimeter says that we have 67 volts. So that means we have successfully connected them in series. And it's wonderful to see the active balancer working also. I also tested up to connect to the BMS, and I did that by just clicking this button, opening the Smart BMS app, which comes from DALI, and then you can immediately see like how charged the battery is and so forth. So it says it has 50% charge, which at 67 would be a lie, because this should be 84 at the top, and well, I haven't really calculated, but 60 something, I guess 50 something at the low end. So when you hear people say nominal, this is a nominal 72 volt battery, which means when it's 50% discharged, it will be 72 volts. But each cell in here goes from 4.2 something volts. I will never get that high again, but 4.2 volts all the way down to 2.6, and the middle value is like 2.6, something like 2.7. So that if you multiply 3.6 or 3.65 or 3.7, I don't remember what the correct value was. Then if you multiply by 21, then you get 72 volts. So let's go on with the battery box build. And I have made a decision there, which I'm not super keen on. But in order for this to fit in the battery box, I cannot put it on top. I can put the Smart BMS on top, but actually that also goes a bit warm. So I don't want heat in my battery box. So I'm actually thinking to put this one outside and then build something on the outside to kind of protect it a little bit. And I'm totally okay with having this exposed a little bit, not directly. I have to build something around it because I do not want the massive heat that might come off this one into the battery box, and it's just going to stick in there. At the same time, when I'm running this one will also create heat, and then the battery cells will, there's resistance in the battery, so when the current is flowing, that will create heat. And then I made the mistakes of using nickel plated steel all the way for these parallel lines and also some of the series. I do not want this heat. I don't want more heat than I'm getting from the battery. I think I looked at some calculation I did earlier on, and at an online calculator, if I'm drawing max from this, which would be like 100 amps at 84 volts, I don't think it matters what volt I would be at, but if I would draw 100 amps, then I would get like 500 watts of energy just converted to heat. And that's just way too much. So yeah, we're gonna start with one motor to see what happens. As you can see, there's a lead wire here, which I'm gonna connect in here. It's a plastic one, so no danger. But it's a heat sensor to see that the battery isn't too hot. So I have actually put this lower than the original recommendation of 5-6 degrees Celsius, just to make sure that I'm not getting too hot up here. I'm going to put this on top of one of the positive poles of the batteries, because that's usually when it gets hottest. So I'm going to have this weird thing where I'm going to put the BMS on the outside. And then I have to pull all these cables, but also these two negatives. So why don't I have a positive and negative? Well, it's kind of simple. The BMS actually only goes from the negative here to itself and then out. So one says B negative, that's the battery negative. And then the P stands for, I guess, load, I don't know, something, load, which is going to be whatever load or charge. So the charging and the discharging, we go through this one. And this one goes to the battery. And everything on the positive side just goes directly onto the positive here. So let's get started with the battery box build.